Hello and welcome to the Networking Lunchbox. Today we're going to look at access control lists. The thing about access control lists is we have to focus on what they're doing and how they're doing it. So the thing we're looking at is just like with this character, it's the glasses. What are they doing? What are we seeing through them? The most important thing to get your head around when you're thinking about access lists is policy. This is a policy. We're setting up a policy. We've got a policy on router 1 that says don't let these guys do video access. We've got a policy on router 2, allowing email and disallowing telnet. We've got a policy on router 3, do not let people talk to the HR VLAN and do not let people get onto the internet to do FTP or Windows Update. The first thing you're doing whenever you're setting up access control lists is think about a policy and what you're actually trying to achieve. Remember back when we looked at the TCP three-way handshake. We've got the client and the server. The client sends a SYN, the server responds with a SYN ACK, and then we acknowledge the SYN and back and forth and back and forth. Now this TCP ACK flag is something we're going to look at a little bit later on, so it's important to remember because access control lists can look into layer 3 and layer 4. Different protocols, port numbers, and the TCP acknowledgement flag. So let's have a quick look at the broad overview of the way access lists work. Access lists are like a filter. You write a policy and you set up individual filters to filter the traffic you're thinking about. So let's say a frame comes in and it's processed. We throw away the layer 2 and now we're looking at layer 3, the packet. So our first policy says which network are we coming from? Network A or network B? If we're coming from network A, we ask the question, are we using port 80 or are we using some other port? So if we're using port 80, then the policy says allow. If we're not using port 80, then the policy says deny. But if you're coming from network B, we have another policy that says if you're coming from network B and you're using port 80, then we want to deny that traffic. And all other ports are allowed through. So think about when you're making your access lists, even though a match might match the policy you've written, the action of that match may be to actually deny the traffic. So you write some policies to allow some traffic and you write policies to deny traffic. Now look in the bottom left hand corner. We've got this nice little chart about the OSI model. IP is layer 3. TCP and UDP layer 4. ICMP is sort of in its own thing off to the side. Just remember as we're working through, if you write a policy to match layer 3, then ICMP, TCP and UDP will all work because they're above it in the food chain. However, if you write a policy to match layer 4, it has to be specific, either matching ICMP or matching TCP or matching UDP. So whichever way you write the policy, if it's a layer 4 based policy, it'll only match that one thing. But if you make a more generic layer 3 policy, everything will match and will be allowed or denied based on what you're trying to achieve. Access lists are all about filtering. We can create an access list to filter based on traffic conditions. We can write an access list to filter management protocols and the way we access our equipment. We can create access lists for different types of networking protocols. And then we choose whether the access list either allows or denies, forwards or drops. So let's have a look at this example. This router has one Ethernet interface and one serial interface. Each interface can have one access list inbound. It can also have one access list outbound. So this router is configured for 3 routing protocols: IP, AppleTalk, and IPX. So the question we have to ask ourselves is how many access lists can we configure to filter traffic on this router? And the math is simple. It's the number of interfaces times the number of directions times the number of route TED protocols. So in this example, we've got 2 interfaces, we've got 2 directions, and we have 3 routing protocols. Give yourself a second to think about the answer. The answer is 12. 2 interfaces times 2 directions times 3 routing protocols equals 12. Access control lists can evaluate traffic based on layer 3 protocols, layer 3 addresses, layer 4 protocols, port numbers, the TCP acknowledgement flag, and much, much more. Now, as far as direction is concerned, think about you sitting inside the middle of the router looking out. So all the traffic that's coming towards you, towards your router, that's in. All the traffic that's going away from you, that's out. So let's have a look at the way an access list actually works. Just a bit of a caveat with access lists too. If you set up a whole bunch of rules and policies and none of those are matched, at the very end of your access list is a deny statement. So anything that isn't matched, it goes all the way to the end, and then that traffic is automatically denied. So it's just as if at the end of every access list you have throw everything away as the very last invisible command. Remember too that access lists are checked in order, top to bottom. So if you have a rule right near the top that does something that's blocking, and then 3 lines underneath that, a rule that's meant to allow, that allow will never be checked. Because once the first match is matched, no further entries of that access list are checked. So let's have a bit of a look at the flow and the way access lists process their data. A frame arrives at your router. Is the MAC addresses matched for that router? No? Well, chuck it in the bin. That's normal. That's completely normal. However, if the MAC addresses match, then we look at, is there an access list on the inbound interface? If there isn't, then begin the routing process. If there is an access list on the inbound interface, does the IP address or the packet type match the entry, any matches in that access list? If the answer is no, then chuck it in the bin. If there are any matches, or there are a match in that access list, does the action of that access list command permit the traffic? If the answer is no, chuck it in the bin. If the answer is yes, then finally we send it up to the routing engine to route inside the router. So we've checked the packet, we've looked at the access list, we've checked for matches. If there are no matches, throw it away. If there are matches, is the action of that match permit or deny? Yes or no? If it's a deny, throw it in the bin. If it's a permit, forward it up to the routing process of the router. So have a guess what the whole right-hand side of this slide is going to be. You guessed it, the outbound action. So on its way out, is there an access list on the outbound interface? If there is, are there any matches? No matches, then too bad. That traffic gets thrown away. Even though it's gone all the trouble of getting in and being routed, on its way out, if it doesn't match the access list, chucked in the bin. So there is a match. Is that match a permit or a deny? If it's a deny, throw it in the bin. If it's a permit, finally we can forward this packet. So everything you've been doing up to now with routing has done this whole process, but all the questions, is there an access list on the interface, have always equaled no. So just come straight in, route it, straight out. But now if you've got an access list on the inbound interface or an access list on the outbound interface, they must be checked. If they're checked, any matches. If those matches are permit, only then will the traffic be allowed. So let's have a look at the command syntax for actually creating our access list. Here's our example on R1. We type the command access list ? And we have all of these different options. So in a numbered access list, we've got 2 broad categories that we want to care about tonight. Standard and extended. But of course what happened is people complained and said, yo Cisco, we need more access lists. 100's just not enough. So they said fine. So they gave an extended range. So from 1 to 99 is a standard access list. From 100 to 199 is an extended access list. And if somehow on the same router you create over 100 access lists, there's an extended range. So you can have another 600 access lists that are extended and another 600 access lists that are standard. But to be perfectly honest, I've never seen it. I've never made more than 100 access lists on a single router. So now, let's say we've created our access list, which we'll be doing in a moment anyway. Now we have to assign that access list to an interface. So we go into the interface and we have to type in the interface command. And then the command for the interface is called IP access group. And this is the way we apply the access list to an interface. So because we've chosen IP, we only get the two numbers we chose on the previous slide because the other numbers are different protocols. So IP access group from 1 to 199 or the extended range or a word, we'll talk about that in a minute. And then we type in IP access group 10. So now we have the kicker, the direction. Are we filtering traffic based on the traffic coming into the router or in the traffic trying to leave the router on its way out? So it's all about the perspective. Now, numbered access lists cannot be edited. Now, yes, I know it's a little white lie because technically later on we're going to show you in more advanced classes that they can be edited, but just for today, and when you're doing your certification exam, a numbered access list cannot be edited. The only way to fix an access list that's numbered is to get the whole thing, put it into Notepad, remove the line that you don't like, reorder it, make the necessary changes, and then paste the whole thing back in one big chunk. So yes, I know if you Google and you do more advanced training, you'll find that numbered access lists can be edited. But for where you are now and for your certification exam, a numbered access list cannot be edited. Let's have a look at the syntax of the access list itself. This is a standard access list, and we have access list 10, permit 192.168.1.64, 00015. Now this is something a little bit different. You may not have seen this before, so let's break it down in its rawest format. Let's take the IP address pairing, 192.168.1.64, and the wildcard mask, 00015. And I've laid those out in binary underneath each other so you can see the actual process that the router takes place to calculate what it wants to do. So we're going to take the IP address and we're going to take the wildcard mask and we're going to run the IP address like through a colander or a strainer. We're going to run that IP address through the wildcard mask. And everywhere there's a 0, we're interested in that value. And everywhere there's a 1, we don't care. Say it again. The IP address and the wildcard mask are a matched pair so that when we mash them together, we get the IP address and a range at the end. Those 4 X's on the end could be any value. And whatever value they are, that will match. So let's make sure we've got our binary and decimal calculations all sorted out. So 192.168.1.1 let's convert it to binary. Does this 192.168.1.1 does this match the test condition of 192.168.164 00015? Give you a second to think about it. No, it doesn't. What about 192.168.1.0? Also doesn't match. What about 192.168.1.128? Does this match the above test condition? No, it doesn't. What about 192.168.1.63? Does that match? Let's check the binary. Oh, checking. Also doesn't match. What about 192.1.64? Let's look at the binary very carefully and see if the last octet, 0100, whatever, does that match? Well, yes, it does. So 192.168.1.64 matches this test condition. What about 192.168.1.65? Yes, that matches. 192.168.1.72? Yes, that matches. 192.168.1.80. So let's compare the binary 0, 1, 0, 0, whatever, 0, 1, 0. Does that match? No, it does not. What about 192.168.1.79? 0, 1, 0, 0, whatever, that appears to match. And what about the last one? That does not match. Look carefully. Read between the lines. We are checking for 192.168.1.64.00015. But that last one is 192.186. Now this is something you have to train your brain to no longer see things in blocks and read every character one by one by one. Now you're probably thinking to yourself, Josh, this binary, there's got to be a better way. Well, here's a little cheat that I'm going to tell you, and it'll take some time, so you should practice this all in binary anyway, but just store this under your hat for the time being. 192.168.1.64 plus 00015 is the range. So 192.168.1.64 is the starting point. 64 plus 15 equals 79. That's the highest number. So all of those IP addresses that have a nice green tick are somewhere between 64 and 79. But you should work it out in binary as well. Now, standard access lists have a bit of a caveat because they only have one area where you can type things. So they only check the source address of the packet that's being routed. So let's have a look at an example. Access list 50, deny 172.16.1.1. Access list 50, permit 172.16.00, 00.255.255. If, when you're making a standard access list, if you forget the wildcard mask, a host address is assumed. 0000 means one address, a host address. If you put the wildcard mask, then it's checked. So for example, the first line there, it will deny just that one IP address. But the second line will permit 172.16.00 all the way up to 172.16.255.255. It's a range statement. Let's have a look at extended access lists. So if a standard access list can only check the source, extended access lists check the source and the destination, as well as being able to check for different protocols and port numbers. So, standard, source only. Extended, source, destination, protocols, port numbers. Let's break it down. So we've got these four statements here. Access list 101. You can tell it's extended because of the number range between 190 and 199. We have permit, and now we've got an extra command. The second command is the protocol type. The third bracket is the source, and the fourth bracket is the destination, and the final bracket on the end is the port number. Now there's something really awesome with the port number. Notice here on line 3, I've just put the number 23. Well, after you type that, the Cisco iOS actually friendlyfies that for you and will replace that with the actual protocol name, Telnet. So the application name, like Telnet. So let's break it down. Line 1 will specifically permit all IP traffic from this one host to anywhere. So basically that first line, if we were to spell that out super longhand, would be access list 101 permit IP 10.0.0.1 0000 0000 255.255.255.255. So the source is a single IP address, and the destination is any IP address ever. So to save us writing out all those zeros and 255s, they've given us a shortcut, the word any. The second line is a more general statement denying all traffic from 10.0.0/24 to anywhere. Bit aggressive, but that's what it's going to do. The third line specifically denies this one host, 172.16.6.1, on TCP only to be able to get to 192.168.1.0 network on port 23. So blocking telnet only to that one host to that network. And then the final line says everyone else on that network, 172.16.6. whatever, can go anywhere they want on telnet. So that's the breakdown of the extended access list and its formatting. Named access lists are the natural evolution. No longer are we now limited by the numbering convention. So now we can create access lists based on a name. We use a friendly name, something that makes sense to us. It's now extended beyond that 800 limit that we were limited to with purely numbers. We can edit and modify named access lists without completely creaming it. Very, very useful. Named access lists have individual statements, so you can delete and add lines one by one if you wish. You can add those statements in the middle or at the end, because by default they're at the end, but now you can add them in the middle if you wish. So let's have a look at the syntax of named access lists. So the first thing we do is type IP access list extended, because we're doing extended, and this is going to be a named access list. Most important thing to notice there is what has happened to the prompt. The prompt now clearly shows that this is an extended access list and it's named, because you've got config ext n ACL. It's a named access list, so you know exactly what you're doing. And now, and the way we can tell that a named access list is a named access list is because it starts with the command IP. Standard numbered access lists just start with access list, but a named access list starts with IP access list. So we call it extended, because that's what we're doing, standard or extended, and then we give it a name. The name, make it a name that makes sense to you. So the command, permit TCP any host 10.0.0 to equivalent to simple mail transfer protocol. Then we press enter, we go to another line, permit UDP from the same host, port 53, which is DNS. And then just like we're programming in normal programming, we type exit, and we take it back to the global config. Then we go to the interface we're trying to configure, and we use the same command as in a numbered access list, IP access group, but instead of a number, we put in the actual name. Now I strongly recommend you using Notepad or something text editor to do this, because the name must match exactly, and it is case sensitive. So if you have uppercase, lowercase, or an underscore or a hyphen, they must match exactly, otherwise it just will not work. So, access list best practices. Once again, that lovely word that I must have said 100 times, policy. Extended access lists must be created as close to the source as possible. Because you've got both the source and destination, you limit and restrict the traffic as quickly as possible. Whereas because a standard access list only has the source, it has to be as close to the destination as possible. I know it sounds a bit backwards, but if you're trying to get to Facebook and you want to block Facebook, you have to put Facebook as the source. So you can only block traffic on its way back. So you have to block it as quickly as possible, so therefore it's got to be as close to Facebook as possible. So if you want to do something like that, strongly recommend extended, because extended access lists should be as close to the source as possible, and they can block things as quickly as possible because they're really close to the source. Whereas standard access lists, not so awesome for that. Statistics. Notice here in the first command we said show access list, and it says line 10 has got 4 matches and line 20 has got no matches. Then we send a ping. Now line 10 has got 8 matches. Now I can tell that we're using Windows because Windows typically does 4 pings in a row. So you can actually tell how many hits each line of your access list is getting matched against. And this is really useful because remember, access lists are matched in order, top to bottom. So you don't want to have a 50-line access list and all the matches right down near the bottom. That's inefficient. So you should have the most heavily matched items near the top because that's CPU cycles you can save. So when you're doing debugging and testing, there's a command, clear access list counters, done. And now when you do show access list, it's empty again. So you send some more pings and you'll get some more matches again. Very useful command. Now remember earlier I said that access lists aren't just for filtering user data, for filtering traffic. Let's look at how we can use an access list to secure our remote access. So we bring up our console. We type access list 23, permit 192.168.8.0, access list 23, deny any log, line v2y 0 to 4, login, password Cisco, access class. So on an interface, it's IP access group, but when you're trying to limit management remote access, it's access class, the number of the access list and the direction. And just for fun, we'll do exactly the same, but the second example, we're going to use a named access list. So it's IP access list standard, SSH access. And then we say our same sort of thing, permit 192.168.8.0, deny any log, line v2y, login local, transport SSH, classic SSH stuff. And now we say access class, SSH access in, end. Now, I haven't talked about this before, but remember I said at the end of every access list, there's an automatic deny. But in the previous slide, we looked at the fact that all access lists have matches. So as a security standpoint, what we can do is we can actually manually add a deny statement. And now we put the word log on the end. What that means is that any match that matches that access list statement is logged to the console. So now, as a security portion, whenever anyone tries to telnet or SSH into this router, if they're not coming from the correct IP address, 192.168.8. something, they're going to hit the second line, which says deny. And that's going to be logged, so we're going to get a message on the console. So now, as we love logging and we love sending all our lovely logs off to some logging source like Splunk, we can very easily go to Splunk and say, hey Splunk, show me how many access list 23s you've recorded for the day. Or show me, hey Splunk, show me how many access list SSH access you've received for the day. And you'll instantly get a report of everyone who has tried to remote into your equipment with their time of day, their source IP address, and which equipment they were trying to hack into. Very, very good tool for auditing. That log command to log the match for that line of the access list. Extended access lists allow you to use port numbers. Remember, source, destination, protocol, and port number. But, like I said before, they have friendlified names. So 23 is Telnet, 21 is FTP, 20 is FTP data. So you can also, remember EQ equals equals. So not equals is NEQ. You can also have greater than, you can also have less than. So I strongly recommend, just for fun, just go into your whatever your router you've got and type access list 101 permit TCP any EQ ? And you'll get a big long list of the friendly, recognizable applications that the access list wants to friendlyify for you, and their port numbers. And if you type access list 101 permit UDP any EQ ? You'll get a different list, because certain applications run TCP, different applications run UDP. So I recommend definitely you doing that and seeing what you get. So let's have a look at this example. We have got R1, access list 103 permit from 10 on port 80. Access list 103 permit from the 10 network on port 443. So hopefully you know that port 80 is HTTP and port 443 is HTTPS. But we also have access list 104, permit from anywhere towards 192.168.10 network. And now we've got this magical word on the end called established. So think way back to the beginning of this video, and I talked about the TCP fin, sin, finac, sin, finac bits. Well, having that established there means that any TCP traffic will match this rule if it is a SYNAC, if it is on its way back from the source. So a PC on switch 1 tries to get to the web server on port 80, and that'll go out through R1 onto R2 onto the internet. On its way back, because it's on its way back, it's the acknowledgement of the first part of the conversation, so therefore it's got that SYNAC field set. So on the way back, access list 104 is verifying that the traffic is on its way back because of that TCP flag for the SYNAC field is set. So anyone on switch 1 can do port 80 and port 443 out, and on the way back, because it's TCP and it's on its way back, it's established, so it'll be allowed through and everything's fine. Can we test this access list with ping? No, we can't, because we haven't allowed ICMP. Remember I said that once you do a layer 4 rule, it's very specific and just that one thing will work. So if we actually wanted to see if we could ping that web server, we'd have to add another line to access list 103 saying permit ICMP any. So broad categories. IPv4 has standard, numbered and named, extended, numbered and named. But with access lists, for IPv6, they threw that all out the window and said no. Named only, extended. So with IPv6 access lists, you don't have to worry about numbers, you don't have to worry about standard or extended. It's just named and extended. That's it. So let's have a look at an example of an IPv6 access list. IPv6 access list and give it a name. And then inside we have deny, IPv6, 2001, DB8, cafe 30. That whole subnet is being denied. So from that subnet, can't get anywhere. And then the second line, IPv6, permit any. So then anything else that isn't 2001 DB8 CAFE 30 will work. And just for fun, to keep you on your toes, instead of having IP access group, they've got IPv6 traffic filter. So just one more thing to write down in your journal. You're not expected to memorize it. So for IPv4 access lists, it's IP access group and direction. For IPv6, it's IPv6 traffic filter, the name of the access list and the direction. So when we want to verify this, exactly the same as IPv4, we type show IPv6 interface and we get to see the access lists. And if we type show access list, we get the access lists all together. Now it's been line wrapped there, so it's a bit hard to see, but the first line and the second line and the third line have a sequence number. And this is what's going to allow us to edit and add and remove later on, because we can pick and choose which one we want to add or remove. And they're always 10 apart by default, so that's to let you add. If you want to add something between line 1 and 2, you would call it sequence 25. And when you press enter, it'll actually inject that command between 20 and 30. And it's just that the fourth line is line wrapped, and that's why it says sequence 70. And you can also tell by the person who drew up this slide for me that they've obviously gone ahead and deleted line 40 and deleted line 60 and line 80 and line 100. So they've been playing around with this access list a bit, editing it before we took this screenshot. All right, and that was access lists. So thank you very much for your time. Thank you for watching, and we'll see you in the next one.